Imagine the most powerful storm you can think of. Picture a tornado, a vast spinning funnel of wind that can lift houses from their foundations and twist everything it touches. Now look up at the night sky and imagine a storm far grander, not of wind and rain, but of space and time itself. These storms rage silently in the deepest parts of our universe. They are created by black holes. Not giant vacuum cleaners in space, but cosmic engines that twist and contort the fabric of reality. The universe's greatest, most silent tornadoes. In this journey, we will explore these phenomena with simple ideas, no complex math. From water swirling down a drain to children spinning on a merry-go-round, simple patterns point to deep truths. Our goal: understand how a spinning black hole grabs space and forces it to spin along. A profound idea at nature's limits. What is a black hole? It is mass squeezed so tightly that its gravity is overwhelming. Imagine the Earth crushed to a marble. Its gravity is so strong that not even light can escape once it gets too close. That is why it is black. Now, space-time. Picture a stretchy sheet. Up, down, left, right, forward, backward, and time, woven together as one fabric. Mass bends this fabric. Gravity is objects following those curves. Around our sun, the curves are gentle and predictable. A black hole makes not just a dimple, but a plunge so deep that anything that falls in cannot get out. Stellar black holes span tens of kilometers. Supermassive ones carry billions of solar masses. Combine a black hole with rotation, and the cosmic tornado begins to take shape. Why do black holes spin? Black holes are born from spinning stars. Like an ice skater pulling in their arms, collapse speeds up spin. Conservation of angular momentum. The result: rotation at mind-boggling rates, even hundreds of times per second. A non-spinning hole is a static pit. A spinning one twists the fabric itself. Imagine a heavy ball spinning in honey. The closest honey is dragged fastest, farther regions more slowly. This is frame dragging, a prediction of Einstein's general relativity. Near a spinning black hole, space itself moves. Engines off, you would still be swept into a circling motion. This is not gas flowing. It is the geometry of the universe in motion. A vortex of pure geometry, the engine of our cosmic tornado. The ergosphere, the region where frame dragging becomes irresistible. It sits outside the event horizon, squashed and egg-shaped around the spinning hole. Inside, you cannot remain still relative to distant stars. Space carries you along. Like a walkway moving faster than you can walk back, you are carried forward anyway. Outside the static limit, rockets can hover, cross inside, and no thrust keeps you stationary. It is a cosmic river rushing toward a waterfall, the event horizon, a swirling region of immense energy, where space flows and time warps. Let's imagine a journey. You launch two identical probes. Probe A aims straight in, yet its path curves as frame dragging pulls it sideways into a spiral. It is forced to join the spin, already in the whirlpool before the horizon. Probe B dips in, jettisons a heavy weight, then fires engines and escapes. Astonishingly, it returns with more energy than it had. It stole a touch of rotational energy. The weight carries negative energy relative to infinity, possible only inside the ergosphere. Like a child on a spinning ride throwing a bag backwards, the rider speeds up. This is the Penrose process, a real physical way to tap a black hole's spin. It hints at how colossal jets from galactic centers may be powered. Why this science matters? It tests Einstein under extreme conditions. Around black holes, frame dragging is enormous and measurable. We also listen to ripples in space-time, gravitational waves from colliding black holes. Their sound encodes masses and spins, letting us confirm frame dragging across the cosmos. The engines of the universe, supermassive black holes drive spectacular jets. Magnetic fields can tap spin energy, a cosmic dynamo powering outflows. Quick fact: a supermassive black hole's spin can store more energy than all the stars in its galaxy over millions of years. Curiosity is in our nature. There may be no immediate application, yet the quest itself changes us. Tools we build for discovery return as advances in medicine, computing, and communications. It enriches culture, a shared story of human curiosity. Like art, music, and literature, science connects us to meaning. It gives perspective and wonder, making life richer. What happens inside a black hole? Our greatest open question. Relativity predicts a singularity of infinite density. Where our laws break down, does quantum gravity rescue reality at the core? Another puzzle, the information paradox. Can information truly be lost? In principle, burned information is recoverable, but a black hole seems to erase details, keeping only mass, spin, and charge. Hawking and others wrestled with this clash between quantum mechanics and gravity. Do all black holes spin? How fast? Where are the elusive intermediate mass ones? How did giants assemble so early? By stars, gas, or direct collapse? Is there a spin speed limit? Do naked singularities exist? Or does nature forbid them? Every observation tests the limits of reality. From earthly tornadoes to cosmic whirlpools of space and time. These objects are engines, not oddities, testing gravity and powering jets. They help shape galaxies, destroyers and creators in one. Centuries of ideas and inventions brought us here, from Newton to Einstein to detectors that feel space-time shiver. A testament to human ingenuity and perseverance. Still ahead, what is dark matter? Dark energy? Can quantum gravity unite the very large with the very small? These questions will inspire the next generation. Next time you look up, remember the silent storms raging in the deep, the cosmic tornadoes of spinning space and flowing time. On this small, fragile world, we can grasp a part of that vast story. The universe is not separate from us. We are the universe knowing itself. Think of space as a river, a flow caused by rotation and mass. Time itself runs differently depending on where and how you move near the vortex. The static limit forces rotation. The event horizon is the point of no return. Spin extraction may occur via particles, fields, and magnetized disks, nature's dynamo. We infer spin from warped light, skewed spectral lines, and flickers from the inner disk. Relativity stands. Nothing outruns light through space. Here, space itself is moving. In summary, spin drags space. The ergosphere compels motion, and rotation can power the brightest beacons. From a storm at a point to the shaping of galaxies, gravity writes the cosmos. The next chapter is being written now, by those brave enough to ask simple questions about impossible places. The quest to know more will never, and should never, end. If this stirred your curiosity, join us for more journeys into the deep.